Ball lightning. Ball lightning is one of the strangest and most debated weather phenomena ever reported. Unlike ordinary lightning, which appears as a sudden flash or branching strike, ball lightning is usually described as a glowing sphere that floats, moves, or drifts for several seconds before fading or exploding. Witnesses have reported balls of light near thunderstorms, sometimes moving close to the ground, through the air, or even near buildings. The difficulty is that ball lightning is rare, unpredictable, and hard to capture with scientific instruments. Because of that, many reports come from eyewitness accounts rather than controlled measurements. Scientists have proposed different explanations, including plasma, vaporized material from lightning strikes, microwave energy, electrical effects, and chemical reactions. But no single explanation has fully settled the mystery for every reported case. That uncertainty is exactly why ball lightning feels so strange. Most weather events can be measured, mapped, and forecast in familiar ways. Ball lightning seems to appear at the edge of understanding, where thunderstorm electricity briefly turns into something almost ghost-like. For narration, it works because it does not behave like the lightning people expect. It does not simply strike and vanish. It lingers. It moves. It appears as a shape. In a storm already full of danger, ball lightning adds something even more unsettling. Light that seems almost alive. Volcanic lightning. A volcano is already terrifying before the sky above it begins to flash. During some explosive eruptions, lightning can crackle inside the ash plume, creating a phenomenon often called volcanic lightning or a dirty thunderstorm. The result looks unreal. Black ash rising from the earth while electric bolts tear through the cloud. This is not ordinary storm lightning, though the processes can overlap. In an eruption plume, ash particles, rock fragments, ice, and water droplets collide violently. Those collisions can separate electric charge, allowing lightning to form inside the volcanic cloud. NOAA's lightning information notes that lightning can occur not only in thunderstorms, but also in volcanic eruptions, intense forest fires, snowstorms, and other extreme atmospheric situations. Volcanic lightning is strange because it combines two forces people usually imagine separately: fire from below and electricity from above. A volcano creates its own storm, not from calm evaporation over warm land, but from shattered rock, gas, ash, heat, and violent upward motion. For people near an eruption, the lightning is more than a spectacle. It can signal how energetic the plume is and how far ash may be spreading. The sight feels mythological, but the science is physical. A mountain explodes, ash rises, particles collide, and the eruption builds a thunderstorm out of the earth itself. Blood rain. Blood rain sounds like a curse from an ancient story, but the usual explanation is far more earthly. It happens when rain carries high concentrations of red or reddish-brown dust particles, giving the water a colored appearance as it falls or leaving red stains after it dries. The Met Office explains that blood rain occurs when red-colored dust or particles mix into rain, though truly red rain is relatively rare because the dust concentration has to be high enough. In Europe, this phenomenon is often linked to Saharan dust. Strong winds can lift fine dust from North Africa into the atmosphere and carry it across long distances. When rain falls through the dusty air, it washes the particles down onto cars, windows, streets, and fields. People may wake up after a storm and find a reddish film covering surfaces. The weirdness comes from the name and the visual effect. Rain is supposed to clean the sky, not stain the ground. When it arrives tinted red, it can feel ominous even when the cause is natural. Blood rain shows how connected the atmosphere is. Dust from a desert can travel hundreds or thousands of miles, mix with clouds, and fall over places far away. The sky becomes a delivery system, carrying a piece of one landscape into another. Raining fish and frogs. Stories of fish, frogs, or other small animals falling from the sky sound impossible at first. Rain should be water, not wildlife. But reports of animal rain have appeared for centuries, and while some accounts may be exaggerated or misidentified, there are plausible scientific explanations for many cases. The Library of Congress explains that animals do not rain, in the same way water does. Frogs and fish do not evaporate into clouds. Instead, many scientists think strong updrafts, tornadoes, or waterspouts may lift small animals from shallow water or land and carry them some distance before dropping them with rain or wind. The result can look deeply strange. A storm passes, and people find fish scattered across a road, frogs on rooftops, or small creatures spread over a field. The weather did not create the animals. It relocated them. This phenomenon is weird because it turns the sky into something that seems to break the rules of nature. One moment, animals belong in ponds, rivers, or wetlands. The next, they are falling into human spaces from above. Even when the explanation is meteorological, the image remains bizarre. It is a reminder that strong storms do not only move air and water. Under rare conditions, they can pick up life itself and drop it somewhere it was never meant to be. Fire whirls. A fire whirl looks like a tornado made of flame, but it begins with heat rather than a thunderstorm. During intense fires, hot air rises rapidly. If winds and local air currents create rotation, the rising column can start spinning, pulling flames, smoke embers, and burning debris into a rotating vortex. Noé Sajink's description of firestorms explains that in some cases rising air can become so fast that it creates a fire whirl, sometimes called a fire tornado. The term, fire tornado, is often used casually, though specialists may distinguish between smaller fire whirls and rarer, stronger fire-driven tornadic events. The danger is obvious but still shocking. A normal fire spreads across fuel. A fire whirl can stand upright, intensify, and throw burning material into new areas. It turns fire from a surface hazard into a rotating column with its own movement. Fire whirls are weird because they combine two fears at once. Fire already consumes. Tornadoes already spin with destructive force. When the two appear together, the result feels almost impossible, as if the atmosphere has learned to twist flame into a living shape. They also show how extreme heat can create its own weather. In large fires, the boundary between fire behavior and atmospheric behavior begins to disappear. Red sprites. Most lightning points downward or across clouds. Red sprites appear above storms, high in the atmosphere, like ghostly flashes reaching toward space. Sprites are brief electrical discharges that occur above powerful thunderstorms, often in the mesosphere. NASA has photographed red sprites from the International Space Station, showing faint red flashes appearing above bright thunderclouds far below. They can be enormous, but they happen so quickly that most people never see them with the naked eye. Their appearance is strange, because they reverse the familiar image of lightning. Instead of a bolt striking from cloud to ground, a sprite glows high above the storm, often with branching or jellyfish-like shapes. For centuries, people may have seen strange flashes in the sky without any way to prove what they were. Red sprites are not supernatural, but they feel otherworldly because they happen at the edge of ordinary human perception. They are too high for normal storm watching, too brief for casual observation, and too faint to notice unless conditions are right. This phenomenon turns thunderstorms into vertical worlds. Below, rain and lightning hit the ground. Above, invisible electrical changes can send red light flickering toward the upper atmosphere. Waterspouts. A waterspout can make the sea look as if it is reaching for the sky. These rotating columns form over bodies of water and may appear as narrow funnels connecting cloud and surface. Some are tornadic waterspouts associated with severe thunderstorms. Others are fair-weather waterspouts, which can form under less violent conditions. The National Weather Service explains that the idea of a waterspout is simply tornado over water is only partly true, because waterspouts come in different forms and can develop in different weather environments. From a distance, a waterspout can look graceful, almost delicate. Up close, it can be dangerous, especially for boats, swimmers, and coastal areas. The rotating column may lift spray, disturb the surface, and move unpredictably. Waterspouts are weird because they visually connect two worlds that are usually separate. The ocean belongs below. The clouds belong above. A waterspout creates a twisting bridge between them. They also help explain why old stories of objects or animals falling from the sky became believable. A rotating column over water has the power to lift small material, carry it, and drop it elsewhere. The sea does not stay flat under a waterspout. It rises into the storm. Thundersnow. Snow usually softens the world. It muffles sound, hides edges, and turns landscapes quiet. That is why thundersnow feels so strange. Thundersnow happens when thunder and lightning occur during a snowstorm instead of a rainstorm. The basic ingredients are similar to ordinary thunderstorm development: instability, rising air, and charge separation. But the setting changes the experience completely. Instead of hearing thunder over warm rain, people hear it through falling snow, often during intense winter storms or lake-effect snow bands. The sound can feel different because snow absorbs and dampens noise. Thunder may seem shorter, closer, or more muted than in a summer storm. Lightning flashes against snow can make the whole sky glow white for a moment. Thundersnow is weird because it breaks emotional expectation. Snow feels cold, slow, and quiet. Thunder feels violent, electric, and alive. When the two arrive together, the weather seems to contradict itself. It is also a warning sign. Thundersnow often occurs in strong snow bands, where snowfall rates can be heavy. The dramatic thunder is memorable, but the real danger may be reduced visibility, fast accumulation, icy roads, and powerful winter storm conditions. In that moment, winter stops feeling silent. It speaks with thunder. Mammatus Clouds. Mammatus clouds look as if the sky has turned upside down. Instead of smooth cloud bases or towering storm shapes, these clouds hang in rounded pouches beneath a larger cloud layer, often under the anvil of a thunderstorm. The National Weather Service defines mammatus as rounded, smooth, sack-like protrusions hanging from the underside of a cloud, usually a thunderstorm anvil. It also notes that mammatus often accompany severe thunderstorms, but do not themselves produce severe weather. Their appearance can be unsettling. A normal cloud seems to float above the world. Mammatus clouds look heavy, swollen, and suspended, like the storm is pressing downward in hundreds of pockets. Sunlight at low angles can make them even more dramatic, casting shadows across each pouch and turning the sky into a strange textured ceiling. Mammatus clouds are not dangerous by themselves, but they often appear near powerful atmospheric systems. That makes them feel like visual evidence of turbulence and instability. They are not the storm's weapon. They are the storm's signature. The weirdness lies in their shape. People expect clouds to billow upward. Mammatus clouds seem to sag from above, making the sky look as if it is filled with hanging bubbles of air and moisture. Lenticular clouds. Lenticular clouds are responsible for many UFO cloud photographs because they can look almost too perfect to be natural. They often appear as smooth, lens-shaped clouds, sometimes stacked like plates, especially near mountains. The National Weather Service describes a lenticular cloud as a smooth, round, or oval, lens-shaped cloud often seen near or downwind of mountain ridges. These clouds form when stable, moist air flows over mountains and creates wave patterns in the atmosphere. Where air rises and cools, cloud can form. Where it sinks and warms, the cloud may evaporate. The result is a cloud that can seem fixed in place even while air is moving through it. Lenticular clouds are strange because they look designed. Their edges can be sharp, their surfaces smooth, and their shapes almost artificial. In the right light, they resemble flying saucers, stacked discs, or giant floating lenses. For pilots, lenticular clouds can signal strong mountain waves and turbulence, so their beauty can come with aviation risk. To people on the ground, they are atmospheric sculptures. Invisible wind made visible for a short time. They remind us that the sky has structure. Air can ripple like water over stone, and clouds can mark the waves. If you enjoyed this video, please like the video and subscribe to the channel. Thanks for watching.